So it's typically very exciting to talk about solutions, but I found recently that I keep talking more and more about problems. And today I will talk about the challenges, which are the problems in virtual assistant technology. So I have some good, nice technology to change the slide here. Okay. So I always like to talk about the history. There are a lot of young people here, and you may not remember, or you may not have been born at the time when the history started. Well, the history started a long time ago, but the first commercial virtual assistant of something which was called Wildfire in 1992. Who remembers Wildfire here? Yeah, a few people remember. So Wildfire was an anthropomorphic user interface on the telephone. It sounded pretty much like a butler that was managing your calls, and executive assistant or butler. And the company was sold to Orange in 2000. Interesting, one of the founders of Wildfire was also one of the founders of the Android operating system, Rich Miner. So it's an interesting piece of history. And I found a little clip of what Wildfire was.
Wildfire.
Here I am.
Call.
Call whom?
Donna King.
Dialing.
Hello, this is Donna.
Hi, Donna. It's Jim Patterson calling. I'm at the train station picking up Ann Kelly as we speak.
That's great news. What time do you think you'll be here?
1:30 as planned.
Travel Airways is calling.
Donna, do you mind holding on a minute? My travel agent's calling on the other line.
Go right ahead.
Wildfire.
Travel Airways is calling.
I'll take it.
Okay, I'll put the current call on hold. Go ahead.
Hello, this is Jim.
Hello, Mr. Patterson. This is a customer service call from Travel Airways. Your 6:30 a.m. flight to San Francisco tomorrow has been canceled. We have scheduled you for the 7:30 a.m. flight, number 145 instead. Is that okay with your schedule, sir?
Yes, 7:30 works fine for me. Thank you for the call.
Not a problem, sir. Thank you for flying Travel Airways.
Thank you. Wildfire.
Here I am. They hung up. Shall I connect you with?
Donna King.
Yes.
You're connected. Go ahead.
Donna?
Yep, I'm still here.
Thanks for holding. I'm glad I caught that call. Our flight tomorrow was canceled.
So this was, it would sound a little bit clunky today, but was the first thing we saw out there. And actually, interestingly, the idea of wildfire spread like wildfire. That was the idea of the name. And what came out of that was the concept of voice user interface. So the voice user interface, the user interface of Wildfire was pretty sleek. And that the speech recognition was pretty pathetic because it was very, very difficult to do speech recognition at the time with the resources we had, with the models we had, and so on. But the voice user interface was so good that it could hide the flaws and the limitations of speech recognition at the time. And of course, after that, I would say that probably the virtual assistant that was the most famous and started it, I would say the virtual assistant Wildfire was Siri. And I don't have to talk about Siri because you guys all know. And after Siri, we had Cortana, we had Google, and Alexa, and so on. So, and I will not talk about Siri because we have here one of the founders of Siri, so he's probably more qualified than me to talk about that. But I will talk about what is in a virtual assistant today. And this is the list of technologies that participated in creating a virtual assistant. So, of course, speech recognition, natural language understanding, dialogue management, language and speech generation. And there's a whole thing that is the real-world knowledge, how to manage real-world knowledge. So how to interpret, starting from the interpretation of natural language understanding, how to come up with an answer or with information that was required. And this is a huge bucket of issues and problems. Let's start with speech recognition. going from speech to text. And the little guy you see on the left is Jibo, is the company I work for, and we have a little bit. I will have a little bit of things about Jibo at the end of this talk. So speech recognition is something that, for me, has been a problem for probably most of my adult life. I started doing speech recognition in the early 80s, and it's always a difficult thing to do. However, today, you've probably noticed the speech recognition accuracy, is pretty good. If you talk to Siri, if you talk to Google, Alexa, you'll be impressed if you live through the dark years of speech recognition. Well, so we may think that today the speech recognition problem is solved, but it is not really solved. For instance, vocabulary is practically unlimited, but many words may not be there. For example, my last name is probably not in the vocabulary of Google or Siri or Alexa. And many other last names, and many new words that come up every day may not be there. So I have a very little clip from an old video that Apple created in the 80s, was called the Knowledge Navigator, and that was a terrific vision of what a virtual assistant would be 20 or 30 years later. And this little clip is a part of that. There is a person interacting with a virtual assistant, and I'm really I found extremely interesting this particular interaction where you see that the assistant does something that today's speech recognition is not able to do.
Okay, let's see. There's an article about 5 years ago, Dr. Flemson or something. He really disagreed with the direction of Jill's research.
John Fleming of Uppsala University. He published in the Journal of Earth Science of July 20 of 2006.
Yes, that's it.
So that's amazing. Today we cannot do that. I cannot go to Google or Siri and say, can you look for a paper of a guy who's a Flintstone or something? Say, no, John Fletcher. So it's impossible today, right? So this is a challenge. Humans can do that. So if we don't attribute magical properties to humans, one day we'll be able to do that with machines, but we are still far from there. So far-field recognition is still one issue, right? One of the issues. What is far-field recognition? And probably you experience here this issue. It's probably with reverberation. So if you have a speaker, and if you have, that's a laser. Okay. If you have a speaker like me here, and a listener, you believe that you're listening to the voice coming from my mouth, but actually you're listening to that, plus all the bouncing of my voice on the walls, on the floor, probably not today because there's a carpet, or on the ceiling and so on. And since the speed of sound is not that fast, it's not as fast as light, it will take a different time from the voice going direct from my mouth to your ears, and the voice that bounces on the ceiling. So it's a longer path, and it takes more time. So this creates the phenomenon of reverberation. And reverberation is particularly deleterious to speech recognition. Our brain is so powerful that sometimes we don't even notice that, and we can cancel the phenomenon. But if you had only 1 year, the fact that we have 2 years helps a lot.
Many factors influence speech intelligibility.
So you see, it's very hard to understand what they say. So and this is what the poor speech recognition system has to listen when there is far field. Of course, if I'm close to the microphone, this doesn't happen. But the farther I get from the microphone, the more and more reverberation I get. So this is one of the challenges today. We are doing pretty well. There are techniques called beamforming and spatial filtering and the reverberation algorithms, but it's something that we can do. We will be able to do better and better in the next years. So the other problem is what is the speaker separation. here I'm the only one person talking, but if you were at a cocktail party, and the party is called cocktail party effect, it will be very hard to separate one speaker from the other. Humans can do that extremely well. I'm still impressed when I go to a bar or a cocktail party and I can talk to the person in front of me and understand what they say and disregard what the other people say. But of course, computers can't do that yet. So let's go to the other big problem, natural language understanding. So the issue with natural language understanding is that while today we may think that the speech recognition problem is sort of solved, I can speak into Siri, I can speak into Google, OK Google or Alexa, and pretty much I get the words that I said. Natural language, which is going from text to the meaning, is a problem that I have not seen solved generally for any particular problem, for any system, regardless of the domain. So it's still a huge challenge. So today, the trend is to use what I call here data-driven machine learning approach. So to use a lot of data that is tagged somehow with the meaning, and then use machine learning to detect, to identify the intent of an utterance and the different modifiers or slots. Unfortunately, sometimes you don't have data. So you have somehow to create data, hallucinate data, or to still you have to handcraft some rules. And the big problem, and the cause of all problems in natural language understanding is the fact that evaluation is very difficult. So speech recognition evaluation is somehow is easy and simple. You speak a lot of many utterances, you see what the recognizer comes up with, and if the words don't match, anytime that the word doesn't match is an error. So if you can measure errors, you can improve, because you can, anytime you have a new algorithm, you can see if it works better than the previous one. In natural language, unfortunately, it's not that easy, because there is not a standard of evaluation in natural language. I can tell you stories about many years ago in the early 90s, when the government, the DARPA agency, funded a project called ATIS, Air Travel Information System, and they provided a corpus for tuning the natural language system from all the different sites that participated in the project, and for testing. And we came up with a committee inside the project to define the evaluation. And we thought that we could define a general set of standard meaning tags. So if someone says, I want to go from Boston to Denver tomorrow morning with American Airlines, which was one of the typical sentences of this corpus, you could say intent is flying, origin is Boston, destination is Denver, airline is American Airlines. So you can create a set of tags that unambiguously identify the meaning in that sentence. But unfortunately, there are a lot of borderline cases. So for instance, if you say, I want to go in the afternoon, what's afternoon? Does the afternoon start at 12 and ends at what, 6 or 7? And what if a flight leaves at 11:59? Is that considered, is that okay? So all these things are all vague. And after 1 year of daily conference calls across the country, we gave up. And we decided that, well, we evaluate a sentence as correctly understood, if the results, the flights that come back from the flights from the database of flights that come back from that retrieval match a set of reference flights that someone found. So, and that's a problem. If you cannot evaluate, it's hard to make progress. Also another problem in natural language is that not everything can be learned. So there are things called entities. So So entities are like dates and times and so on. So, and that is a problem of grounding. So there are sentences like, tell her she did not bring her car. Take the chair next to the sofa. So these are very highly ambiguous sentences that if you don't know what's happening around, you cannot. Language and speech generation is another problem. How to speak. Speaking well is not much easier than understanding well. There are different methods for what is called text-to-speech. Today, one of the methods mostly used is statistical again, so learning how to speak from corpus. The problems are intelligibility, naturalness, and then the actual language generation, generating text from semantics. Dialog management, keeping track of what is said and done, interpret current input, select the next things to do, and so on. There's a lot of work on statistical-based dialog, but today we don't have commercial statistical-based dialogs. Dialog systems are mostly handcrafted. So to end my talk, I will give you some details about what I'm doing today in the company called Jibo. And we are building a social robot that is more than a virtual agent. Why? Because it has a body. It has a body and it can see and can, besides talking and understanding and so on. So this is Jibo. So this is a technology that goes into Jibo. There are many microphones around. There is a stereo camera, so you can see where you are and also how far you are. There are speakers to talk, of course. The body is touch sensitive. The face is a high definition touch graphical display, and there are 3 motorized sections. You can do a lot of things like storytelling, messaging, video chat, and so on. But the most important thing that we will come up with an SDK. Actually, the SDK was released to a small number of developers last week, and we will have a general release soon for everyone to use the SDK. And to end my talk, these are also the technologies that are there: speaker identification, speech recognition, natural language understanding, data management, all the things that I spoke about before. But Jibo has all the problems I told you before, plus one. It has a body, so you need to also manage the body. So, and because of that, we have an Jibo SDK. So we have a short video that was actually available on YouTube that talks about the SDK.
Hi, I'm Jonathan Ross. I'm the SDK team lead here at Jibo.
And I'm Francois Levers, principal.
Sorry for the shorts, it was a hot day.
We're excited to share some of the technical choices we made surrounding the Jibo platform, and to share some of the first glimpses of the development tools. From the beginning, we wanted the SDK and development environment to appeal to web, mobile, and game developers. Instead of developing our own custom runtime environment for Jibo's skills and reinventing the wheel, we decided to build off the momentum of a platform that developers were already comfortable with. That's why Jibo runs all its skills in Electron. Electron is an open source project started by the folks over at GitHub. It elegantly combines the IOJS runtime with the rendering engine of Google Chrome. So anyone who has done web or node development will easily transition to writing Jibo skills. All of our platform APIs are written in JavaScript and packaged as a node module. They are designed with inspiration from animation and game engines. But because they're designed around a single character, we've been able to streamline the interface to be both simple yet powerful. They give you control of Jibo's speech recognition, sound localization, text-to-speech, and touch sensors, and an animation and inverse kinematic system, as well as access to Jibo's perceptual and social abilities.
We're very excited about our tools. We built all of our tools as a plugin to GitHub's Atom editor. Installation and updates are simple with Atom, and it works on OS X, Linux, and Windows. The best part is that Atom is built on top of Electron, and because the tools share the same runtime as our skills, it allows us to execute the very same code that lives on the robot in our SDK and in the simulator. Our plugin includes 2 powerful authoring tools. First, our animation editor, which is inspired by both Flash and Maya. We streamlined it for animating Jibo's unique form factor. This makes it easy to create animations that bring Jibo to life. Second, our extensible behavior editor lets you coordinate expression and sensory input into encapsulated, reusable AI components. We're very excited to see what people develop with our tools. We're looking forward to working with the community and continuously improving our developer experience. Stay tuned for more videos.
All right. I don't know if you could, I couldn't understand a word from here, probably because of the reverberation. Could you understand that? Yeah, okay, good. So this is the end of my talk.
Well, thank you very much, Roberto.